you for joining us for the IEEE Computer Society Standards webinar series, brought to you by the Standards Activities Board. With over 225 standards that transform the way we live, work, and communicate, the IEEE Computer Society sets the standard for design automation, simulation, testing technologies, Ethernet and Wi-Fi, quality assurance processes, systems architecture, DevOps, and more. Standards deliver best practice processes for developing market-ready interoperating systems, products, and services. You can have an impact by joining one of the over 200 IEEE Computer Society Standards working groups. Participating in one of the working groups grants you access to information that reduces risks, increases proficiency, and shapes the future of the industry. Help determine what's next in computing technology. Learn more about our standard working groups at computer.org/standards.
Hello, everyone, and thank you for joining us today, and welcome to today's webinar from our Standards Activities Board series, and today's webinar from the IEEE DevOps Working Group. My name is Scott Levine, and I'm the membership manager here at the IEEE Computer Society. Before we get started, I would like to address some housekeeping items. This webinar is being recorded. You can ask any questions in the Q&A box you see on your screen, and the speaker will answer as many questions as he can following the presentation. If possible, please reference the slide your question refers to. A copy of the slides and the recorded webinar will be emailed to you tomorrow. Here at the IEEE Computer Society, we are dedicated to providing the latest research and resources within computing. This includes the IEEE Standards for DevOps, which can improve IT controls while achieving compliance objectives. Keep up with the standard and more by checking out our ongoing calls for participation and get involved with the Standards Board activities. As a part of the network, you have the opportunity to connect with professionals from all over the world. Additionally, with the Society, you have the opportunity to discover and learn more from our digital library, which features over 682,000 papers and articles highlighting the latest research in reliable systems. Furthermore, you can grow with other professionals through various events such as technical communities, conferences, and chapters. Information will be shared with you after the webinar, and you can always learn more at computer.org. Circling back to today's presentation, DevOps can help to accelerate the delivery of features to your customers by implementing popular DevOps practices, including continuous integration, delivery, and deployment is not without risk and many challenges. This webinar will discuss how to use IEEE and ISO industry standards to achieve your goals, even in industries where there are strict requirements for regulatory compliance. No matter your field, these strict regulatory and compliance requirements can create barriers to accelerated delivery. Using the IEEE standard for DevOps, building reliable and secure systems, including application, build, package, and deployment, you can strengthen your IT controls, achieve compliance objectives, while also accelerating delivery of value to your customers. Joining us today is Bob Aiello, a DevOps CM ALM architect, trainer, and coach who has led process improvement initiatives across leading financial services, medical, and engineering firms with a focus on software and systems security and reliability. Bob is chair of the IEEE 2675 DevOps Working Group that recently completed a comprehensive DevOps industry standard cross-adopted by ISO EIA. Bob is also the current chair of the IEEE P828 Configuration Management Standard Working Group and an IEEE liaison to ISO for Agile and DevOps, as well as an IEEE liaison to SAEG 33 Configuration Management. Bob is active with many ISO working groups and is a longtime member of the IEEE Software and System Engineering Standards Committee Management Board. He believes in spreading industry best practices through publications and on social media. In addition to his leadership activities, Bob has written hundreds of articles and several books on CM, ALM, and DevOps. Bob, thank you so much for being here today, and the floor is yours.
Thank you, Scott. It is a pleasure to be here, and this is a real fun topic. We will be talking about using DevOps in a very practical way to understand how to build software and systems that are reliable. And of course, there's a focus on application and systems, build, package, and deploy. I'll show this slide at the end, not because my picture is pretty, but at the bottom is my LinkedIn link and my email address if you'd like to get in touch with me, and particularly if you've got questions after the webinar. So let's see. Lectures, symposia, seminars, or educational courses, and individual presenting information on IEEE standards shall make it clear that his or her views should be considered the personal views of that individual rather than the formal position, explanation, or interpretation of the IEEE. And that is 100% true, and everybody who knows me knows that I've got a lot of personal opinions. But today's focus is going to be on DevOps, and the DevOps focus itself is very much on how to accelerate delivery of the features. We want to be able to get new features of our software and our systems to folks real quick. We want to provide customer value. We want to be able to update the system in the middle of the day. You know, years ago, we only updated systems on, say, a Friday night or over the weekend. And I used to call that an admission of failure, because the assumption used to be that it would take us 2 days to fix whatever we broke. So now we have things like a well-ironed machine. We can do an update in a few minutes, and we can do them in the middle of the day without affecting our customers. Now, we're also going to focus a lot on managing risk, and risk is not bad. Risk allows you to understand, what's the risk in me making this change? What's the risk in me not making this change? And to be able to maximize our success through an intelligent approach to risk. And we'll talk about that a little bit more. And DevOps very much changed the game by bringing out the fact that developers and operations folks have different perspectives, right? Developers want to go fast. Operations folks want the system to be up for more than 24 hours without breaking. And the truth is, they're not the only stakeholders, right? Users have a perspective. You have smart QA and testers who have a perspective. You have a cybersecurity perspective. So the whole point is to have a balance of perspectives. And another area that the DevOps movement really focused on is that too often organizations have these silos where they fail to communicate outside of the silo. And so we're not going to eliminate the silos, because in many organizations you need a certain organizational structure, and we'll talk more about that when it comes to regulatory compliance, but we're going to eliminate the negative impact of silos and help you understand how to communicate more effectively across the entire organization. Now, there's lots of DevOps practices. I'm just listing a few of the more common ones here, and we're going to talk about this in depth. We talk about continuous integration, where we have developers really integrating their code on a regular basis, delivering code out to the end user. And we make the distinction between continuous delivery and continuous deployment. Now, some thought leaders are using these terms interchangeably, but let me give you my definition of continuous delivery versus continuous deployment. Continuous delivery, to me, we do in a smooth fashion without disrupting the user. I may push a feature out in a dark fashion. It's turned off. I'm using something called feature toggle. It doesn't really show up in the user's face until I'm ready to turn it on. But I'm still updating the target system. Continuous deployment tends to be more disruptive. Now, why would I want to be disruptive? Maybe I'm pushing a security patch out the door. And, Equifax would have liked to know about this. Sometimes you have to put a change out there really fast. And even if it's a little bit disruptive, you can't take a risk that the known vulnerability could result in your system being hacked. And there have been many public incidents, including the Equifax one that I mentioned, where the real problem was that they didn't have the capability to push those changes out as quick as they needed to, even though they knew they had the problem, the vulnerability. Fully automated procedures. If you're doing things manually, then you're going to make mistakes. So early on in my career, I found that I didn't want to think that I'm so smart that I can always get it right. And sometimes you're tired, sometimes you're just not in the mood. So I used to automate everything because that gave me more confidence that I wouldn't make mistakes. And then we ran into some situations where my boss said, "Hey, Bob, you're going to be off for a day. I'll cover for you." And then I was absolutely scared to death because my boss, as much as I love the guy, he wasn't as technical as he thought he was. So I had to build automation so that a trained monkey could do it and get it right each and every time. Shift left, doing things smarter, better, sooner, so that you're building in quality from the very beginning of the system. We'll talk further about that. Continuous everything, I'm going to define this in detail, but we talk about continuous integration, delivery, and deployment. What about continuous testing? What about taking a continuous approach to security, reliability? And for those of us that have vision impairment or other disabilities, continuous accessibility, making sure that your website can work if somebody's using a screen reader or has some other disability. And feedback loops. I mean, these are just some of the most common DevOps practices. There's many more, but the whole notion of constantly looking for feedback. How am I doing? Are there better ways to do things? Don't be afraid to get that feedback and continuously improve what you're doing. So, industry standards and frameworks help you define the requirements as well as what you expect the outcomes to be, the activities and the tasks. They focus on what to do, not necessarily how to do it, although we're going to get into a lot of the how to do things. They help to measure your current and desired state. This is really important. The only way to be really successful at improving your processes is to assess what you're doing today. Ask people what's going well, what could be improved, get a baseline of how you're doing things today, and then compare that to the practices that we talk about in these industry standards and frameworks. And we'll give you a few specific ones to really use. And that helps you come up with your plan for how you're going to improve things. If you're a big bank, a financial services firms, medical, pharmaceutical, aerospace, defense, automotive, engineering, you've got federal laws that you have to follow. And that's true of any country that you're in. You can't just do things in a haphazard fashion. So these standards and frameworks help you pass all those regulatory and compliance tests, and that's really important. Standards and frameworks can be challenging to understand and implement. And that's why we come in with these webinars, because we kind of lift up the rock and help you understand not just what we've written, but how to operationalize the processes. And I want to be careful to say, we're not interpreting the standard for you, but we're explaining how to use it in practical terms. And I'm a practitioner. I've written several books. They're used in graduate programs. So, sometimes I get to visit the classroom and give a lecture, which I love doing. But, I'm a guy that does this at 2:00 in the morning. I'll update medical systems that matter, where if I get it wrong, a lot of people are impacted. So a lot of what we're going to talk about today is very practical stuff. Now, it is important to understand DevOps is not without risk. It costs money to do things right. It's going to take you a little longer if you're going to automate everything. And you got to make sure you've got that ability, the time, the lead time, and the resources to be able to implement DevOps, because it's not free. It'll pay for itself over time, but it does take some initial investment. Knowledge, take some expertise to do this stuff, and you're going to be sharing knowledge with other people and have that capability. When I dig into systems, it's not trivial. You have to actually know what you're talking about. There's a perception that DevOps is a magic bullet. It's not. I joke about sprinkling my DevOps pixie dust in meetings, but it's hard work. It's not just a magic bullet. There is no magic. It's doing things the right way and thinking them through. It is a culture change, and you have to do that change in a way that aligns with the existing culture, because you can't just come in and change how people are working overnight. You have to understand the culture of the organization that you're in. If you're in a government agency, they have a well-defined culture, and you have to implement these practices in a way that aligns with what they're doing, and it will drive a lot of change. So the people side of this, especially communication, is really, really important. Velocity. A lot of times I can implement the ability to change systems faster than companies can keep up. The QA team, the testing team may not be automated enough to keep up the rapid rate of change. So if you really want to understand DevOps, how did we get here? DevOps is a new term. It came into play in 2009. Patrick DuBois and some other smart people were in conferences, and they had the realization that systems could be updated faster, and they proposed this balance of perspectives that I mentioned earlier between developers who want to move fast and operations who wants to be careful. And so the DevOps movement was really understanding that there are these different perspectives, and as I said before, include all the right stakeholders. One of my books in 2016, I went through the full life cycle and all the different stakeholders and understanding their perspectives. Your QA team has got a view, your business end users. Sometimes the business end users they've got a bigger appetite for risk than I do, and I have to understand their perspectives to realize why taking the right level of risk makes sense, even more than I expected. So DevOps practices, including automated systems and applications, build, package, and deploy, and that focus on culture, that is really how we got here. And I'll talk in a few minutes about the impact that configuration management really had on DevOps as well. So some of the first practices around version control, build engineering, configuration control, they were in place and popular way before 2009. And so CM, configuration management, particularly modern configuration management, really was very, very popular long before any of the folks came up with the term DevOps. CM tends to dig more into the ingredients, and towards the end of this talk, I'm going to invite you to join both the CM working group, and we're updating the configuration management standard, as well as the new DevOps study group that is forming to work on the next version of the DevOps standard. But within configuration management, we have legacy practices. And I won't go too deep. This could be its own webinar, which I'd be glad to give. But, legacy CM is used in places where they're, say, manufacturing brakes for cars or train manufacturing, where they have to follow certain safety guidelines. And these practices of configuration identification, status accounting, change control, and configuration audit, they've been around a long time, and they're really important. And they're also pretty detailed and specific. We also have modern CM, which involves automated build, package, and deployment. And there are some emerging practices around the software bill of material, supply chain, and managing dynamic libraries. That is very much the work of the new IEEE Configuration Management Working Group. Join us in those meetings if you're interested in how configuration management is evolving. And both DevOps and configuration management are evolving fast. There's a lot of opportunities for us to improve the security and reliability of systems, and we are running with that and really focusing on how to develop systems that are inherently built to be verifiably secure and verifiably reliable, free of defects. So a good way to look at this is configuration management, a lot of the seminal practices, DevOps, and there's a core chunk of that. I'm not sure if maybe it's a little bigger than I've shown in this diagram. A good chunk of those practices, like around build pipelines, really are shared by both CM and DevOps. DevOps is not a merging of development and operations. There are some folks that are spreading that rumor. Ain't going to work in a big bank. If you merge your development and operations groups, you're going to be in a regulatory violation. And, organizations like the Fed may drop a letter on you and tell you that you're about to be out of business. So be aware that, some of the folks that, it's not new to try to say developers can deploy their own code into production. You also can't do it. So even though I know some of my colleagues are spreading this, it's not going to work if you're in any kind of a publicly traded firm or company that engages in activities and business that involves regulatory requirements. So there are rules that are required. So, for example, banking and finance. There are the Fed as well as FDIC and other organizations oversee banking and finance, and you can't just have developers loose in production because they can modify the code to do illegal transaction and push money into their own banking accounts. That there have been movies about that, of course. Medical, pharmaceutical, life support systems. I've been very involved with an organization hard at work fighting COVID for the last year or so. It's been super fun. So medical systems, you have to update them fast, and you have to do it in a very careful way. Engineering, automotive, aerospace, really, according to Section 404 of the Sarbanes-Oxley Act of 2002, any publicly traded firm has to apply and follow these rules. So what are some of the real requirements? Segregation of duties is one. The person who writes the code should not be the person who pushes it into production. That's a really important rule, because if you write the code and you push it into production and you go on vacation, what are we going to do? If you write the code and you give it to me and I rebuild it from scratch, and then I have some automated procedures and I push it into production, and then you win the lottery and stop working, I have a way to pull out that code and show someone else how to build it so we can support the system. Segregation of duties is a really important practice that helps reduce risk and protect the interests of both the firm and the people who use the technology. Say you're trying to get to your banking account. You want that bank to be adhering to these regulatory requirements. Control the changes and not just making changes without evaluating them, having the proper testing in place, really guarding publicly private information, protection of protected health information, or PHI, as well as the right to be forgotten in GDPR. So security and reliability, there are many of these IT controls, and I'm not proposing that they be very verbose. Really, I take a lean approach, but they are important, and also in many industries they are federally required. So some of the other practices, left shift, starting to do the right things earlier in the life cycle. I find this is the most common problem organizations have. An organization may start doing the right thing before the code goes into production, but they didn't practice it, so they make mistakes. If you get them to start doing the right thing instead before the code goes into QA, then they have a chance to practice, make sure the scripts work right. Then when we do it to production, it's a slam dunk. So left shift is very important. Designing systems to be verifiably secure and reliable, building and testing and security from the beginning, and taking that risk-based nature. So understanding that security, reliability, testing, quality assurance, all these things, as well as accessibility, being able to make sure your systems can be used by somebody like me who may use a screen reader at times or have another type of disability. They are continuous things. Too many companies try to tack them on at the end. That's not going to work. You really have to approach things in a continuous fashion. And we talk about that a lot in the DevOps Standard. So we're going to be looking more in depth at the DevOps Standard in just a few minutes. So some folks talk about DevSecOps. So sure, security is a critical aspect of DevOps, but so is testing, quality, risk analysis, security. So if you want to talk about DevSecOps, you have to talk about Dev, test, QA, risk, security, reliability, ops. That's why I just say DevOps. Taking a continuous approach is always a good idea. So let's take a look at what's actually in the IEEE standard that has become an ISO standard. We have agreement processes that help you acquire software in a reliable and safe fashion. We have organizational project enabling processes around how you handle your life cycle, your portfolio, knowledge, quality, and we have technical management processes around project planning, decision, risk management, and technical processes. How about requirements, architecture, design, and implementation? And we'll also talk about things like retiring assets that are no longer in use. Now, one of the cool things that we did when we wrote the DevOps standard is we looked at standards like ISO 12207, which is this wonderful full lifecycle standard that looks at best practices throughout the entire software and systems lifecycle, and 15288, which takes more what we call a systems view. We followed those standards very closely. So you can see, and I'm going to show this to you in just a minute, we quoted like the introduction or the purpose from 12207, and we followed the exact same outline. So if your company is using other ISO standards, you're going to find this DevOps standard fits in beautifully because it's outlined in the same way. And the configuration management standard and many others, we spent a lot of time making sure that the guidance and the advice that we give in the DevOps standard aligns perfectly with these other popular industry standards that help you build reliable and secure systems. So this is just to give you like an idea of the outline. I don't expect you to read this. We have the purpose that we pulled from 12207. We put that into the DevOps standard. Then we describe the outcomes, and then we go into in detail in the activities and tasks, and I'll show you that. So every one of the processes, and you can see we have a lot of them, every one of the processes takes this type of outline of quoting 12207, so you have that full life cycle view, describing what your outcomes are going to be, as well as the activities and tasks. So some of the common themes include the right stakeholders. Too often we don't do a good job of pulling in the right people and getting their perspective, assuming that things are going to change. Things are going to change, so assume, design for rapid change and constant change, automate everything. Spend the time and effort to create the right tools, left shift, and taking that continuous approach. So there's a lot of common themes that you're going to see throughout 2675 that pop up. Now, I'm just going to give you an example. If you're going to purchase a product, you have to go to the company that you're buying from as part of the acquisition process and have a strategy for acquiring that software. Make sure that you've got your requirements for the product that you're purchasing well defined. Make sure you've specified the service level agreements and service level objectives. Understand the risk of getting that product. Could that company go out of business? Are they really in a position to support you for the long term? Review the vendor policies, including security testing. Sometimes I've traveled to companies we're going to acquire a banking system from and found their configuration management practices really were not good. Now, if you're on the other side of the coin and you actually have a product that you're selling, then you're the supplier, and you should be prepared to share what your practices are in very much the same way as you expect other vendors to share them with you. So let's switch to organizational project enabling processes, such as managing the full life cycle, understanding infrastructure management, portfolio, human resources. If you don't hire the right people, you're not going to be able to do DevOps. If you don't have a quality management process in place, you won't be able to handle the rapid rate of change. So with lifecycle management, we have to make sure that the whole lifecycle management process is ready to keep up with the speed of changes that you get in any DevOps organization. So if it's an infrastructure management process, then you have to make sure you've got the right communication mechanisms in place. Is your networking team communicating with the other infrastructure members of the team? I find that's often a big issue. The security services, are they involved throughout the whole life cycle? Do you have procedures so that you can replicate the environment? Or do you have a situation where your QA environment is different than production? If you automate building your infrastructure, or what we call infrastructure as code, then what you build for QA will match what you build for production. So infrastructure management processes is really important. Human resources. You got to really include the folks who are hiring people in your organization if you're going to move to being a DevOps organization with a DevOps culture. You have to hire people that are into being part of a team, that they've got the ability to learn new technologies, and as I've mentioned a few times now, that they can keep up with the rapid rate of change, because things are going to change very, very quickly. Quality management. You have to make sure the products and services meet your quality objectives. So a DevOps mindset changes this approach because you have to achieve the customer's objectives. Too often folks will say to me, we built the system to the requirements, but are you sure the requirements were written well? I find often folks write requirements, and until they see the product, they don't really know how to verbalize what they want. And I've seen this over and over in my career where everybody tried to define the requirements well, but they didn't understand what the customer's objectives really were. So in quality management, we have to make sure that we're not just building that our requirements are well defined. We have to make sure we build something that's going to be able to function with its intended use. So this is where DevOps practices really help, because I can throw up a prototype pretty quickly and show it to you, and that helps define the requirements and helps you with this iterative process, including making informed decisions and achieving customer satisfaction. And this is all about customer satisfaction. Knowledge management. In a DevOps organization, the number one thing you're going to hear me say is, can we share a screen? Can you teach me what you know? I don't want the DBAs working in a silo. They are a silo, sure, but I want them to teach me what they're doing. I want to teach them what I'm doing. All of the technology professionals do a lot of knowledge sharing in a DevOps organization, and that is really key. So software development, testing, quality, infrastructure, security, operations, I will get with the test team and say, show me your test automation. Let me actually see it. Let me show you some of the things that I'm doing so that you understand the system better. Establishing the automation of just-in-time processes, workflow orchestration and scripting, developer and infrastructure tool stacks. So being able to share knowledge is a key aspect of having a true DevOps organization. Now, the technical management processes, this is a whole other area. Project planning. A lot of organizations think, well, we're agile now. We don't do any project planning. We just have Scrum. We have a backlog. There is an important aspect of having the right level of project planning, not where you create a book and you just put it on the shelf, but where your project planning is enough to reduce risk, to make sure that you're communicating to those who are giving you a couple $1 million to build that system. You're assessing, controlling processes, handling decision management, risk management, configuration management, information management. The technical management processes are actually really, really important. So, with project planning, we want to make sure that we've defined the outcomes, the deliverables, the processes, the resources, and the risk. And I've talked about risk quite a bit in this presentation because it's a key aspect of DevOps. I take more risk in a DevOps organization because I can. And if I can manage risk in a smart way, then I also can increase profits. So I may push out a release that is, has a little bit of risk to it because I have the ability to respond if something goes wrong, and there's enough of a business reason to take that risk, that there's a reward for doing so. And all the stakeholders, we've communicated with them, hey, we could take another 2 weeks to work on this version, but if we put it out there in beta, our customers may enjoy getting a chance to see, what we're working on. And you know what? We're going to throw a little button in there that they can click on a button and go back to the legacy system if they don't like what we've done. So, there are techniques in DevOps where we can start to preview new features that are coming out there and manage those risks and for the better. To set up execution and maintenance to support the QA team is really important. So being able to use these practices for real requires a higher level of process capability. And that's, that's a lot of what we talk about in practical terms. So the risk management process, this is really important. It's a continual process from the very beginning. You want to address risks throughout the life cycle of the system. You need an iterative, continuous, and information approach. And you want to be able to automate the identification, analysis, and treatment and monitoring risk. You can't do things manually. Manually, it's gone. You have to spend the extra time writing automation when it comes to system monitoring, when it comes to identifying and fixing things. You're going to be doing much more automation if you want these capabilities to really work. So CM, configuration management process, purpose is to manage and control the system elements, manage the ingredients to bake in the pie. Configuration management manages the consistency between a product and its associated configuration identification or definition. CM can really be its own standard. Actually, it is, P828, and I'll talk about that at the end if you'd like to get involved. So CM is a part of this standard, but it's also its own standard. And it's a really key area if you want to have secure and reliable systems. So quality assurance, making sure that you've got the confidence that the requirements, the system was written to the requirements, and that the system will be implemented in the way that it is expected to be. Technical processes. This is a whole other area, and there's a lot to it. There's business, mission analysis, systems, software definition requirements, architecture definition. Are you really communicating your intended architecture throughout the whole organization? I find a lot of companies take a siloed approach to this. They have 3 or 4 smart people who define the architecture, and then they don't necessarily communicate it to all the other people in the organization to get their input, and also to make sure that everybody understands the target architecture. So these technical processes are really important, including integration, verification, transition, validation, operation, maintenance, and disposal. We'll talk more in depth about them. So the purpose of stakeholder needs and requirements is to make sure that you can provide the capabilities needed by the users, extend the stakeholder group, make sure you're including the right people, that you're considering both functional and non-functional requirements, and allowing any stakeholder to really be able to voice their opinion and to get involved in the process. It's important to be inclusive. Systems and software requirements definition, again, look at this from the point of view of things are going to change. New technologies are going to pop up. This is not one of those things where we're building a mainframe system we can design for 2 years and then implement for 2 years, and then the mainframe system stays, static for the next 10 years. Things change fast. 6 months is a long time in our business now. Systems analysis, make sure that you're including the networking, infrastructure, computing systems, and services. So with each of these functions that I'm giving you a taste of, we go through the outcomes, the tasks, the approach to each of these so that you understand how DevOps changes the game. And yeah, there's some common themes, but each one of these also has very specific requirements that you really do need to consider. So implementation, if you want to implement this, make sure you take an incremental approach. So you want to do things in a continuous fashion. Make sure that you're adhering to audit and regulatory processes, because if you're doing this for a big bank, they do have rules that you have to follow. Otherwise, you're going to get that letter from the Fed. verification is very important. Making sure that you verified that the system meets the requirements. We'll talk about validation next, where we want to make sure the requirements are correct. But verification, making sure that your continuous testing is continuously verifying that your system is going to meet the requirements as they are defined. Transition. This is transitioning the system from test into production. You have to make sure you've got the right practices in place so that your transition of the system into operational status is handled in a continuous way and facilitated by automated procedures. You cannot do transition in today's world, especially if you want to be a DevOps organization, unless you're making heavy use of automation. So validation, I mentioned before, verification focuses a lot on, making sure that you adhere to the requirements, but you also have to think, is this fit for use? Can I use the system to achieve my business objectives? And I got to tell you, a lot of times the folks who write requirements, whether you're an agile organization or you're doing Waterfall, they mean well, but it's often hard to really understand and verbalize all of the requirements. So validation makes sure that even if the system meets the requirements, does it meet its intended business use, which is really important. Operations. Look, somebody's got to be minding the farm. Someone's got to make sure that the systems stay up, that you can respond to any incidents that occur, that you know who to communicate if things go bump in the night, and that you've got automated procedures to handle any type of event that occurs. Maintenance, being able to make changes in an iterative fashion, being able to control the changes to be able to maintain your system is of course really, really important. And disposal. If there is a function that many organizations forget, and if you're familiar with a company called Knight Capital, they really had a tremendous loss. They failed to deprecate components of their system that were no longer in use. If you leave systems, software, or hardware on your system that are no longer in use, not only is that a security vulnerability, it's a reliability vulnerability. In Knight Capital's case, they had a terrible trading disaster, in part caused by the fact that they had failed to remove a part of the system that was no longer in use. So being able to dispose of, to deprecate parts of the system in an orderly fashion is really, really important from both a security and a reliability point of view. So I ask you to get involved. We have the 828 configuration management group. It's operating right now. We are having so much fun. We meet on a regular basis, and we're going through SBOM, emerging practices. We just did asset management, a lot of cool stuff. And we're creating the next version of the IEEE's Configuration Management Standard. We're working with a lot of other organizations. We're really out there. It's not just the IEEE. We're involved with a number of other organizations. And the DevOps Working Group, which was dormant while we were going through ISO cross-validation, that group is reforming now. We're going to form as a study group and figure out what we're going to include in the next version of the standard. Both these groups certainly keep me busy, and I invite you to join them. I'll give you my email address once again. You're going to learn more by being involved with these projects than any graduate or doctoral program, because this is the real deal. And you'll see that you're on you're in a meeting with 15, 30 people who are really super smart, very knowledgeable, very experienced folks as we go through the most participative experience you could ever have writing these standards. Really, really lots of fun. So, once again, if you look at the bottom there, my LinkedIn invitation, LinkedIn link there is LinkedIn/in/Bob Aiello, BOBAIELLO. Please, if you send me a LinkedIn invitation, we're all getting spammed a lot on LinkedIn lately. Just say that you're at my webinar. That'll help me out a lot. Or my email address is bob.aiello@IEEE.org. And so let's see. I did have a couple more that we could throw in at the end, but let me pause there. And Scott, do we have some questions from folks?
Yeah, great presentation, Bob. We do have a few questions, so why don't we jump into those?
Absolutely.
First question, does DevOps only work in agile organizations?
No, and I'm glad I got that question. I really should have talked about this. Agile organizations must use DevOps. There's no way to keep up with the rapid rate of change inherent in an agile world without using DevOps. But the reverse is not true. I have worked with organizations that had to use waterfall life cycles. They just, they'll just say to me, hey, you know what? It takes 6 months for us to fabricate the chip, and we're writing the software to go in that chip. So, there's just no way we can do a 2-week sprint. And DevOps works fine in an iterative waterfall environment. And if you know waterfall really, you'll understand that it was originally envisioned as an iterative process. So DevOps can work in both agile and non-agile environments, but agile must have DevOps in order to succeed. Scott, next question.
All right, great. Next question. How do I convince my boss to let us do DevOps?
I tell you, if you have to convince him and he's not aware, him or her, and he's not aware of what's involved, it can be a tough task, and people are going to ask how much is it going to cost. There's also a lot of misconceptions. So the way that I usually approach this is that I do an assessment first. And this is really a key practice. I assess what's going well, what could be improved. I sit down and I talk to a good number of key stakeholders. And obviously, this is where you may want to consider bringing in an outsider like me. But I ask people, what's going well, what could be improved. And then I form the list of what are the things that really do need to get improved. Now, I don't start with the hard things. I start with 1 or 2 easy things. I compare that list to industry best practices, including the DevOps Standard. And then that's how I form that map. And that's what I use to sell to senior management. Hey, if we spend the time and effort, I'll give you a simple example. I've gone into organizations and they have the most complicated branching strategies you could ever imagine. By getting them to go to a simpler branching strategy, we literally gave them back a week in their development cycle. That was a week every month that they could write code instead of dealing with bad merges. And it turned out that they had adopted an unnecessarily complicated approach to how they were handling version control. So that was just one of the things that we saw right away when we did the assessment. Another might be the way that they're handling build engineering. Frankly, sometimes I find that, you've got 1 or 2 people understand Ant, Maven, and Make, or, some other build technology. Well, having some lunch and learns and spreading that knowledge around. Again, DevOps is a knowledge organization. It's cool to share what you know. Spreading that build engineering expertise around can solve a lot of problems. Scott, got another question?
Yeah, this question is from Frank. Says, great work, but is the dev operation culturing a research process?
I'm not sure I understand what that question means, but I don't think that it's a research process, cultivating a research process. I'm not sure I fully understand that question, but I will tell you that, as we know, the basic spirit of DevOps was that developers like to go fast. Operations likes things to be static and reliable, but they're not the only stakeholders, including the test team, including the security group, in bringing the business end users in. I worked on a financial system in a startup, and the testing came back, and they had a lot of defects in the code. And I threw down the red flag, and I said, this release has to get postponed. We're not ready to go to production. And the business end user came to me and sat down with me and said, Bob, I need you to hear me out on this. If we go live this weekend, we know the system's got a lot of bugs in it, but all the trades are going to note the fact that we were first to market and was a very innovative new product. And we had several competitors on our heels trying to introduce the same sort of system. So the business end user said to me, I'm okay with taking the risk that we may crash every day for the first week. But I really want to get out there and be first, because our salespeople are going to rake it in if we're the first ones that introduce this new technology. So he taught me that the risk of not putting this buggy software out there was far greater than the risk of putting the buggy software out there. So I went ahead. We all sat at our desks and rebooted servers, and we tailed the error logs, and we all dealt with some fairly unreliable, software for the first couple of weeks. It turned out to be the first few months, but our salespeople raked it in. We made a lot of money. So understanding risk from a business perspective may be a little different than a tech guy like me was thinking about, but it's really, really important. Scott?
Yeah. Okay. Next question. I'm not sure what letter this is due to the font. There's no stairs on the font I'm seeing. But maybe you can decipher this for me, Bob. What is, it's either an Istar or Lstar requirement engineering model. Does that ring a bell to you? It's typed in as an L or an I with an asterisk.
I actually don't see that. Let's see.
That came in through the attendee chat.
Say that again?
That came in through the attendee chat.
So I believe that it's an I. So can you give me that question again?
What is an Istar requirement engineering model?
Okay. So in other words, there's many different functions. So it's Istar. I'm assuming that there's different functions, just like I always say that it's continuous everything. It's continuous testing, continuous integration, continuous deployment. I'm not sure what the Istar is. Maybe whoever wrote that could give us a few examples that would help. But I do think the notion of having a consistent approach all across the whole technical stack is really, really important.
All right, maybe as a give us a little bit more, we can go to the next one. Can you give suggestions for people who are just getting started with DevOps? Sure.
So I think the first thing is don't focus so much on the name. It's a buzzword. I mean, we practically have people selling DevOps ice cream these days. Vendors basically claim all their products are DevOps. So focus less on the name. If you're just getting started, write a lot of code, write automation, do things in an automated fashion. When I write code, I assume I'm a complete idiot. And every line of my code checks every line of my code to make sure that I didn't mess up. So I often describe to folks that copying a file is really 4 steps. I look at whether or not there is already a file by the same name in the target directory. And maybe it's read-only. Maybe I can't override it. So if I'm copying bob.x to another directory where it's going to be bob.x, I got to make sure the target directory is writable. So that's the first step. Then I calculate the size of the file, or perhaps a cryptographic hash like MAC-SHA-1 or MD5. And then I copy the file and I recalculate the hash, make sure the whole thing got there. Because sometimes in the copy, it gets truncated, and then I log the results. So one little copy line is actually 4 transactions, and you got to make sure that when you take a DevOps approach, you're writing code so that really is testing itself, that really is foolproof. So scripting a lot, writing a lot of code, working with other folks, DevOps is definitely full stack. You cannot just say, hey, I'm only going to do Java. Not in this world. You've got to be really comfortable working across different technologies, different cloud-based providers. I can be doing a build for a C++ application, one day and be doing a completely different technology stack the next day. I might be working with mobile apps. I might be working with, web applications or websites. So DevOps involves a lot more experience because you should have done some development. You should have done some operations. So the most important thing to start with is making sure that you've written scripts to automate things and that you take that bulletproofing approach so that you're always testing to make sure each line of your script actually worked. Scott?
Great. This person had to ask about here we go, some clarification. I think this same person asked about the Istar requirement. What do you mean by, I guess this is a follow-up to what you just said. What do you mean by business standard compliance and requirements validation?
Okay, so when we write a system, right, most big companies, particularly if it's a complicated system and I'm giving you $10 million to do it, I'm not just going to let you go off and build whatever you want. You have to write requirements and tell me what the system is going to do. So I remember one time I did this at the New York Stock Exchange, and I got the sense that the business end user defining the requirements wasn't really communicating well with the technology folks who were writing the code. So I challenged that guy to meet with me for an hour and write test cases, simply write what they wanted to test and what they expected the results to be. Within the first hour, the guy picks up the phone, calls the head of development, and says, what I have asked for is not what I need. And I only started to realize it working with Bob, realizing what we had to do to test it. Folks, when they write requirements, they do their best to say what the system should do, but until you see a prototype, until you get a little further into it, it's often hard to really understand how the system is going to be used. So there's both requirements validation, but there's also fitness for use. In other words, can the system perform its intended function? So that's the difference between really writing a system for requirements versus validating that it can really do the function that it has to do. Scott?
Excellent. Is DevOps all about CI or CD?
So continuous integration is important. Continuous delivery is different than continuous deployment. I mentioned that earlier. Continuous deployment tends to be more disruptive, at least that's the way I define it. And I'm well aware that some of my colleagues reverse those two definitions. Continuous delivery tends to be a little more graceful. We do things through feature toggle, but it's the notion of putting code out there in tiny increments instead of a big bang deploy, which is always very, very risky. So taking things, a continuous approach, as well as testing. What about security? Do you get security folks involved from the beginning so that you're building the system to be inherently secure? You cannot tack on security at the end. So it's really, really important to build things in a continuous manner, continuous testing, continuous risk analysis, continuous, really continuous everything is a key aspect of the right way to do DevOps. Scott, got one more?
Yeah, we have one more, it looks like. How can I tell if my organization is ready for DevOps?
Good question. Not every organization is ready for DevOps. Sometimes you got to let them really fall. If they've had a disaster, often that's when they're willing to change and consider new ways of doing things. So it's a good question. I'd say if you have support from the top down and from the bottom up, then you're ready. But I've walked into organizations that maybe had a few problems, and I was able to use that to get them to consider new ways of doing things. So every organization can improve things. Don't call it DevOps. Just call it making things better.
All right. That sounds like great advice. That looks like the last of the questions. So, Bob, thank you again for being here today. That was a really great and engaging presentation. And I'd like to thank everyone for attending today and being here with us and to help contribute with a really lively Q&A segment. Just one quick programming note before we wrap up. The Computer Society has a few upcoming webinars later this month. On November 10th, we have a webinar from our Distinguished Visitors Program on deep learning, and from our Build Your Career webinar series, we'll have a webinar on how to manage up on November 15th. You'll receive a link to register for those and all of our other upcoming webinars in the email you receive tomorrow with the slides and the recording. Again, I would like to thank Bob Aiello for joining us today and sharing his great insight. Again, thank all of you for attending and have a great rest of your day.
Thanks, Scott. It's been a pleasure to be with you.